Here, in the nearly pristine marine environment of Antarctica's Ross Sea, in an area called Erebus Bay, a group of researchers based at Montana State University continues one of the longest-running population studies ever of a long-lived mammal. The subject? Beautiful Weddell seals, the southernmost mammal residing on our planet. But why study Weddell seals in Erebus Bay?
The Earth is interconnected. The systems on Earth, our water, our air, are all connected. We certainly know that things like El Nino and La Nina are a very global phenomenon that move Earth's air and water around. And so the things we do back in our homes and in our home countries certainly affect other parts of the world.
You might say, well, so what? What's the big deal with Erebus Bay seals and why put so much effort into it? Well, the processes, the ecological processes that are going on here with this big-bodied, long-lived animal are the same processes that I study in Yellowstone Park. In the park, I study grizzly bears, wolves, elk, and bison. They all have the same sort of life history characteristics. They're big-bodied, they're long-lived, they are slow to mature. When they get into the old age classes, they become physiologically senescent. So those attributes of the two systems, even though one's marine, one's terrestrial, are very similar. But here, the big predators, these Weddell seals, are easy to work with. We can walk right up to them, we can tag their pup. We can't do that with a grizzly bear in Yellowstone Park.
And focusing on this particular population of Weddell seal gives researchers a great opportunity to learn more about ecological processes.
The Ross Sea has been described as the most pristine marine ecosystem left in the world. And so it's an outstanding place for us to try to understand the complexities of how climate interacts with ocean systems and then affects the marine ecosystem from primary production in the planktonic community all the way to the top trophic predators like whales and seals and penguins.
Then there are the Weddell seals themselves. And what's amazing about these animals is how well they have adapted to this environment.
One of the real beauties of studying Weddell seals here is we're getting to study a species in a place where they really work quite well. And I use the analogy of a doctor getting to study a healthy patient, and it's nice to know how a healthy person works if you want to try to help the sick. And so in a lot of places in work with wild animals and conservation, we're working with populations that are endangered or have had some bad things happen to them, and we're trying to figure out how do you save them. Well, it's very helpful to have studies of populations that work really well. It serves as a baseline of information over the last 30 years of how do they work when they're working well. Should things change down here and the system go in some other direction if we exploit the fish too much, or if the climate were to change down here, we would be able to see the signal in the population.
This study, arising out of the initial work in the early 1960s by Ian Sterling and developed by Don Sineff and others from the University of Minnesota beginning in the late 60s, is now continued with Bob Garrett and Jay Rotella of Montana State University, working with Don Sineff. Numerous graduate students have worked on this project over its many decades of Antarctic research history.
It is one of the longer running studies of a long-lived mammal. There are some that are longer, but most are not. And so this is certainly a very special data set that's been collected by quite a variety of people over the years, and we're kind of the current group that's in here and has the privilege of being the caretakers and the collectors and curators of the data.
Over the long course of this study, researchers have found this population of Weddell seals to be very stable. But in the past decade, these seals faced the challenge of an extreme environmental event, a giant iceberg that blocked access to their pupping areas.
One of the interesting things we learned just in the last few years on this National Science Foundation funded research is that we have had a major iceberg event, a very, very large iceberg that we know had very dramatic direct effects on some of the penguin species. On the seals, we didn't have a direct dramatic effect in the very first year the iceberg broke out. But eventually, as that iceberg blocked the bay, the ice got thicker and taller. Some of these ice blocks that you see here were towering, made it very difficult for seals to get in and out of the water. Very difficult perhaps to get back here because the ice was very thick and very jumbled.
But to understand more about how these seals dealt with the massive iceberg event, well, let's back up a little bit and learn more about these amazing animals.
Weddell seals are found only in Antarctica. They're a true seal, Phocidae, and they're one of several truly Antarctic seals that are only found in this part of the world. They're one of the better diving marine mammals in the world. We know them to be a seal that swims back in under the frozen sea ice, and they come up through the tide cracks. And around here on against these islands, we have places where the ice is attached to the shoreline, and then out here the tide goes up and down a few feet. It's about a 1 meter tide, maybe maximum in this area. And the seals use that diving ability to get back in here and come out through these tide cracks and exploit this area. One of their tricks in life is to get back in to have their pups away from anywhere where there's any predators. And for the first few weeks of life, the babies are wearing this lanugo coat, this fleecy looking coat. They're not very fat yet when they're brand new, and they're not waterproof, so for a while they're really, really visible to us up on the surface. And then as they get a little fat from mom's milk, they'll start to swim, learn some skills in the water, and then they'll be a little less available to us for our work. The next part of their life, they sort of disappear from here. The first couple years of life, they're not around very much in the colonies, the breeding colonies. There's some evidence that they go out into the pack ice and probably exploiting fish out in those areas, although it's not that well understood yet. And then at some point around 3, 4, 5 years old, they'll come back into these colonies and start to give birth, maybe have a pup every 2 out of 3 years on average. Start giving birth at about age 5, 6, 7, somewhere in there. And then they'll have 1 pup a year is the maximum, maybe a pup every 2 to 3 years. So most animals that are born like a pup like this, most of them don't make it to adulthood. The first couple years of life, they got about a 50-50 chance of surviving. But if they can make it out to about age 3, the survival rates get very high. They're getting bigger, they're getting stronger, and probably know their way around and have places they know to find food and shelter and so on. If they make it out to age 3, then they can live to about 15 years old. The oldest seal we've ever had is 30, but probably not very many make it that long. That's pretty rare. So when we see a 20-year-old or a 25-year-old, those are pretty old seals.
And the researchers know all of this because of the tools they use to study these seals. From the very simple low-tech tools like small livestock tags and weigh scales, to extremely high-tech statistical analytic tools.
So there's 2 fundamental activities in the field season. The first half is focusing in on visiting all the colonies and tagging every pup, or almost every pup, that's accessible, that can be safely accessed, soon after they're born. Then the second half of the study period, we have very standardized surveys where we travel throughout the Erebus Bay, all the colonies, all the sea ice, trying to find every seal that's hauled up in one day. Since the 1960s, over 20,000 seals have been tagged in the Erebus Bay area.
We now know how long they live. We know when they start to have pups. We know how often they have pups. And from that, we assemble an understanding of their life history.
How do we tie population dynamics with variability in the food that's in the marine system that's probably driving those population dynamics? Well, since we can't study the prey themselves, we can infer that in years when the conditions are good in the raw sea that produces a lot of food, a lot of fish for the seals, that the seals probably gain more weight that year. And so when they come back to reproduce, on average, they're going to be bigger than in years where food's relatively scarce in the marine environment. So we can't measure food directly, but we can measure mass as a surrogate. We've developed a whole line of additional research that's layered on top of the population dynamics that's all about how much do you weigh when you come in and give birth to a pup? How much of that weight do you transfer to the pup over the period of nursing? How big is that pup when it's born, which represents the contribution of that female, the reproductive investment of that female in utero? And how big is that pup when it's weaned, which represents the female's investment in that pup, her mass investment in that pup to get it as big as possible, so that when it's weaned and it's independent, it's starting out hopefully with a better chance of surviving those first tough years when it's learning how to forage, where to go.
So with decades of information on this population of Weddell seals, the project was well positioned to track what happened to these seals when the huge iceberg event blocked access to their pupping areas.
A couple years after the iceberg broke, we had a major drop. We had typically around 500 or so breeding females and very tight tolerance, very little fluctuation around that number. During that major iceberg event, we had the population plummet to only about 225 animals, so a halving. That year we dropped to about half of the population and lost several hundred of the animals.
As a whole, reproduction was lower during the iceberg events, but in 2004 it was the lowest reproduction rate ever recorded during the 40 years this study has been existing.
When that happened, we did not know, were those animals just gone? Did they die? Were they crushed? Did something happen to them? Were they blocked somewhere where they couldn't find food and they starved? Or did they find safe haven somewhere and hang out through the lean times? As the iceberg broke up and the sea ice went back to more normal conditions, I'm happy to report that the seal numbers went right back to where they had been in the past. And so that was really interesting information to gain. But the other thing was that it was the same seals came back. So it wasn't that the seals had gone away permanently or had died. The seals had been somewhere surviving those difficult conditions and then went right back to business. And then it wasn't too long after that before we had the record number of pups ever produced. So within a couple years after the end of the iceberg, we had probably the largest number of pups ever produced in the last 30 years. So it's very interesting to have the long-term work that allowed us to have the long-term perspective on that baseline, and then to have a major environmental event of an iceberg happen, drop those numbers, and then to see how the seals responded. They responded very cleverly by going and persisting, staying alive, and then coming right back when conditions were good again. But the other thing is really interesting is it allows us to use historic baselines to measure those changes. You know, oftentimes we don't have data going back for decades in a pristine environment that's really been left alone by humans to the extent possible. And so just knowing that that was within the normal realm of variation from one year to the next, that it wasn't that big a deal, was interesting. The other reason it's really interesting to look at the seal response to that iceberg was if a climate model that said we were likely to see more big iceberg events like that because climate change perhaps was going to lead to calving of more and more big bergs like that. This allows us to realize that as long as they're spaced out in time and as long as the ice goes back to being an ice sheet, that the seals can handle that. The other thing we would realize from this is that if you were to have events like that persisted for many, many, many years, there's no doubt about it that the seals would face a very different world because their strategy was to wait it out. Well, you can only wait it out for so long, and at some point, if there's nowhere to go and haul out safely and have those pups, then you would have a problem.
The past decades of research have demonstrated that Erebus Bay Weddell seals, despite living in the most extreme southerly environment capable of supporting mammals, are well adapted to cope with the natural environmental variation that's inherent in the Ross Sea ecosystem. But this last pristine ocean ecosystem is now being affected by human activities, and continuing the study will allow scientists to evaluate both the resiliency and limits of this ecosystem into an uncertain future.